that I didn't teach them really good. I did. All right, P6. 2 more lessons left from this chapter. We have P6 and P7. So P6, we're going to focus on complex numbers. All right, I have 3 parts today. First thing we're going to do is just an introduction to what complex numbers are. Second one is operations that we're going to do with them, adding, subtracting, multiplying. And then part C will be the division because it involves conjugates and something totally different. All right, so here we go. Letter A, an intro. Complex numbers are weird, right? And you know why they're weird? It's because your whole life you didn't know about these numbers, that they even existed until last year. And you're like, what? You tell me some different numbers are there? It's weird. So like, for example, here you are over in real land, and you know all about real numbers are split into 2 different types. There's rational, which is abbreviated with the letter Q, which is kind of strange. And there's irrational, which is abbreviated with the letter I. There's 2 types of numbers under real. Rational, you can be rational or you can be irrational. What's a very famous irrational number? Pi, yeah, pi. From rational, you could be an integer, which is abbreviated with the letter Z, because there's already an I right there. And then from integers, you could be a whole number, and then you can be a natural number. And you learned that probably the first week of Algebra 2, you learned it in Algebra 1, you've learned it and learned it and learned it. Then, all of a sudden, we said, no, you know what? Let's go ahead and talk about these numbers over here. They're not even part of our real number system. They're their own numbers. They're complex numbers. Now, real numbers can be inside of there, okay, but complex numbers are not inside of there. I'll explain that a little bit better in just a minute. Now, complex numbers came about in the 17th century. I know this because I took the history of mathematics, and it was very good. 2 classes of it. Yeah. Early, excuse me. Early history and late history. So in the 17th century, things like this were going on. They were like, oh, how do we solve something like this? F of x equals x squared plus 1, and we want to solve it to find zeros. Well, it has no real zeros. In other words, what number I plug in to square it, add it to 1, I can't get 0 from that. So how are we going to do this? Well, let's make up our own number. Really, that's what they did. And there was a big math war about it. People were like, no, and the derogatory term was, oh, those are just imaginary. You guys are imagining them. And then it stuck. It was kind of cool. All right, so here we go. Let's talk about what the imaginary unit is. So the imaginary unit, and this is all review. You learned all of this last year. The imaginary unit is called I. And I is equal to the square root of -1. Okay? So a lot of people will say, oh, we're going to do imaginary numbers today, and that's fine, like 5i, -3i, 4i. Those are all imaginary numbers. But when we talk about complex numbers, that includes imaginary numbers, but it also includes it when you have a real part and an imaginary part. So complex numbers are of the form a plus bi. Those are complex numbers. They're very complex. Imaginary numbers are complex numbers. Real numbers are complex numbers. Okay? So some examples of complex numbers would be 5 plus 2i. 5i is also a complex number. -7 is a complex number. I know that sounds weird. You're like, no, that's a real number. It is. But it's a complex number. When b equals 0, you get -7. If a was -7, of course. Things like that, okay? So a is the real part, b is the imaginary part, and that's what complex numbers are. Alrighty. Oh, also, I squared is equal to -1. That's very important. And that's the first time you ever squared something and got a negative number. And it didn't make sense. It was weird, right? Because these are not real numbers. They're not going to show up in real life a lot of times. Sometimes they do, which is interesting. So let's take these complex numbers and let's do some stuff with them. It's very fun. We're going to do some basic operations. basic operations. So when we're doing operations with complex numbers, you have to know that you cannot leave any powers of I in your answer. I cubed is not allowed, I squared, because those can all be simplified and broken down. Like, what is I cubed? For example, I cubed, yes, it's I times I squared. I squared is -1, so instead of writing I cubed, we would rather write negative I, because that's the answer, okay? So everything has to be simplest form. So let's start. Number one, let's say we have this complex number, 7 minus 3I plus 4 plus 5I. Every year I put a problem like this on my Algebra 2 quiz, and someone foils it. It drives me crazy. That is not a FOIL problem, is it? FOIL is multiplication of two binomials. This is addition of two binomials. Totally different, right? But you see the parentheses, you see the binomials. Oh, FOIL. All right, it's not FOIL. We're going to add. Basically, we're just going to add the like terms, right? We're going to add the real parts together, add the complex or imaginary parts together, and get a complex number. 7 and 4 make 11. Negative 3I plus 5I is 2I. And really, you don't even have to know what I is to do that. It looks like you're just adding like terms. Okay, so that was a nice little warm-up. Number 2. Ooh, let's subtract them now. Subtracting's, a little harder than addition, and people forget to distribute the minus sign. That's where they make their most mistakes on this problem. Some people still will FOIL that out. It's not a FOIL problem. But we're going to subtract. 2 minus I minus 8 plus 3I. And when you subtract, you have to subtract everything. So we're subtracting 2 minus 8, and what do we get? Good, -6. And then we're going to subtract negative I minus 3I is -4I. Good. All right, so I'm insulting you again with how easy this is, right? Number 3. I just yelled. All right, let's go 5 times 3 plus I minus 2I. So still some basic operations. We're going to use what property says that we can take that 5 and multiply it inside the parentheses? Distributive property. Good. Do you remember that? Does that ring a bell? All right, go ahead, distribute that in. 5 times 3 is 15. 5 times I is 5I minus 2I, 15 plus 3I. Okay. If you want to do that in your head for homework and you don't need to show work on that, that's fine, okay? That's a very simple problem. But when you're foiling like we're going to do right now, you need to show your steps. I don't want just answers, even if you can do it in your head. Congratulations, you're a genius. No, you're going to, if you want full credit on your homework, you're going to show me the work, okay? Even if you can do it in your head. So we're going to do 2 plus 3I. And we're going to FOIL that. We're going to multiply that times 5 minus I. All right, and this is like any basic FOIL problem. We're going to do first, outside, inside, last. 2 times 5 is 10. Outside gives us negative 2I. Inside gives us 15I. And my last term gives us negative 3I squared. I did that quickly because you can do that quickly. You've FOILed so many times in your lifetime. It's amazing. All right, now what we're going to do is we want to fix this last term. So the last term is negative 3I squared. What is negative 3I squared? It's 3. It's 3, right? This is negative 3, and I squared is -1. So this is really just 3. Okay, and now we're going to combine our like terms. And by the way, complex numbers are always written as real plus imaginary, okay? That's just the order. It's just the correct way to write it. So 10 plus 3 is 13. Negative 2I plus 15I is 13I. And that would be your answer. Nice, huh? Number 5. All right, a couple more. How about this one? 4 minus 3I squared. Okay, if you know how to take a binomial and square it using a shortcut, that's great. If you don't feel confident or comfortable doing that, all you need to do is rewrite this out and FOIL it. Okay? But don't forget there will be a middle term. So I'll even have some of my calculus students that will take a binomial squared, and they'll just square the first term, square the last term. It drives me crazy. What's that? Julio's here? Oh, much to your dismay. Oh, I said that on tape. Okay. I love you, Julio. Shout out. Can I go back and erase that? Never mind. Okay, here we go. I'll just record in my next class instead. 4 times 4 is 16. And outside is negative 12i. Inside is negative 12i. And then my last term, be careful here, it's negative 3 times negative 3 is positive 9. And I times I is I squared. Do you guys remember doing this last year? Yeah? Yeah? A little bit? Okay, and 9i squared, what is that? Negative 9. Perfect. 16 minus 9 is 7. And negative 12i and a negative 12i combined to give us negative 24i. All right, one more of these and we'll move on to the next piece. Number 6. How about this one? 3i to the 4th. Okay, 3i to the 4th. Simplify. In honors algebra 2, did you guys go up really high, like I to the 78th power and stuff like that? There's like a pattern that you follow. Yeah. Yeah, that's fun. All right, so we're going to go 3 to the 4th and I to the 4th. What is 3 to the 4th? Do you know that one? 81. You said that a minute ago, huh? Like 10 seconds ago? Yeah, and I ignored you. I'm sorry. I didn't know you were just shouting out numbers. I was like, okay. No, but you were right. 81. Good. I wasn't there. Hey, you made it. Yay. All right. I to the 4th. Now, what I like to do, just to make sure that I get it right, yes, you're correct, is I like to do I squared. I like to break it down into its squares. I squared and I squared. So I know I squared is negative 1 and I squared is negative 1, and that times itself gives me positive 81. Fun, huh? All right. Let's move on to, this one's tough. I'm sorry. This was the last one. I turned the page. I have one more. Number 7. So everything we've done so far today has been Algebra 2. You might be bored to death. Maybe it's me. Maybe it's the math. Maybe it's just the level. But we're going to jump it up right here, okay? I'm going to tell you that z is equal to, a lot of times they'll use z as a complex number. Z is 1/2 plus rad 3 over 2i. And we're going to find 2 things for this problem. Letter A, we're going to go ahead and find out what z squared is. Awful, right? Isn't that gross? Yeah. And then I'll tell you about part B. All right, so z is equal to that complex number. We're going to take that and multiply it times itself. So really, we got a FOIL. We have 1/2 plus rad 3 over 2i. And we're going to multiply it times itself. 1/2 plus rad 3 over 2i. So not only do you have I, but you have fractions, and you have radicals all in one problem. Your favorite things. So here we go. First, 1/2 times 1/2 is 1/4. Outside gives me rad 3 over 4i. Inside gives me rad 3 over 4i. We're going to combine those in just a minute. And then my last term is rad 3 times rad 3, which is 3. 2 times 2 is 4. And I times I is I squared. Is everyone okay with that? Fractions, radicals, I. All right, so we get that this over here, instead of 3/4 I squared, is what? Negative 3/4. And what is 1/4 minus 3/4? Negative 1/2. Perfect. Negative 1/2. All right, and then the middle term, I have 1 rad 3 4i plus another rad 3 4i gives me how many of them? 2 rad 3 4i's But that can be reduced, and you get negative 1/2 plus rad 3 over 2i. It almost looks like what we started with, doesn't it? Super close, huh? Okay, so then what they're going to do in the homework for part B, they're going to ask you, what's z cubed then? So z, yeah, your face explained it right there. You're like, oh, that's horrible. But we already did z squared. So isn't z cubed just z squared times z? Yeah. So let's take, don't sigh like that. That's not allowed in here. That's -5. Wow, your grade just plummeted. Okay. Negative 1/2 plus, that was really funny. Rad 3 over 2, not me, his sigh, that was great. And we're going to take that. That's z squared. We just found that. And we're going to multiply it times z. Well, what is z? My z is way up there. 1/2, it's positive. 1/2 plus rad 3 over 2i. It's going to be worth it, though. It really is. You'll see. You don't believe me now, but it is. It's a really cool answer. Okay, so let's FOIL. Here we go. Negative 1/2 times positive 1/2 is negative 1/4. Outside gives us negative rad 3 over 4. Inside, oh, don't forget that, sorry. Inside is positive rad 3 over 4i. Ooh, you see that? That's going to cancel out. Yeah. Okay, and then my last term, rad 3 times rad 3 is 3. 2 times 2 is 4i squared. This isn't difficult. It just takes a while, right? But you have nothing better to do. Seriously. Yeah, no, than this. You don't. All right, so this right here is negative 3/4. These are opposite. That's really fun. So I get negative 1/4 minus 3/4 gives me what? Negative 1. Oh, see? Totally worth it. Worth it. All that work. That's good, huh? Nobody cares? Okay. All right. But what does that mean? What is that going to do for us? Nothing. It's just fun. Okay. All right, so let's do the last part. Ooh, do I really have 5? No, we're at 11, right? Okay. Keep thinking lunch is next. It's not. All right. We're going to do some conjugates. Conjugates. Now, let's say that z is equal to a plus bi. Then z bar, that's what it's called, z bar. It's the place I'm going to after work, over to z bar. Thank you, I'm here every day. Okay, z bar, I'm not. Actually, I'm going to the club. The Sam's Club with my kids. Yeah, it's true. We need some corn dogs and stuff. Okay. Z bar is equal to a, yes, they come in this 30 pack and they last us for months and months. You don't get corn dogs there in the frozen section? They're delicious. I don't eat them, actually. I think they're gross. Okay, Z bar is equal to a plus bi bar. You can write that as a bar right there. And what this is equal to is the complex conjugate, which is really a minus bi. Very complicated looking mathematical symbols that you don't get. But basically all it's saying is that z and z bar are complex numbers. Now, what's the big deal about z and z bar? Well, if you take z times z bar, you will get a real number. That's the major thing about it, okay? So, we're going to use this when we divide. When we divide complex numbers, you're not really allowed to divide them, but you can use their complex conjugate to get the correct answer. You did this last year too. You may not remember. What number are we on? Let me go back. 7. We're on 8. Okay. Number 8. So let's go ahead and divide 2 divided by 3 minus I. Okay? So you can't take 2 and do a little division symbol and 3 minus I. You can't cancel stuff out like you want to. What you're going to do is you're going to take the complex number of the denominator, the complex conjugate, of the denominator, and you're going to multiply numerator and denominator of the fraction by that number. So what is the conjugate of 3 minus I? 3 plus I. Yeah, all it does is it changes the middle sign. Everything else stays exactly the same, only the middle sign changes. And when you do that, you get 6 plus 2I over, and you can do this in your head. This is pretty easy to do. 3 times 3 is 9, right? Inside, outside always cancel out with complex conjugates, every time. And then negative I times positive I is negative I squared. And you really get 9 plus 1, which is 10. Okay, but that's not your answer, so you have to reduce. What goes into all three of those numbers? 2. 3 plus I over 5. There you go. And you're like, okay, why is that 3 plus I over 5 better than 2 over 3 minus I, right? You're not allowed to have I in denominators. It's just a rule. You have to get it out of there. That's the only way you can get it out of there. Number 9. Okay, last one. 5 plus I, sometimes they get a little more complicated like this one, over 2 minus 3I. Okay, we're going to take a complex number, 5 plus I, we're going to divide it by another complex number, 2 minus 3I. So what we're going to do, instead of dividing, we're going to multiply by the complex conjugate, and we get to FOIL a couple times. By the way, let me tell you real quick, if you're doing A plus BI times its conjugate, A minus BI, your answer will always be A squared plus B squared. It's a little shortcut for some of you if you like to memorize that or just know that. It's always going to be A squared plus B squared. Look in this one. A was 3, B was negative 1, 3 squared plus negative 1 squared, 10. Okay? Always. All right, so let's multiply top and bottom by 2 plus 3I. That's the conjugate of our denominator. So up top, we got a FOIL. FOIL this out. If you want to kind of skip a step in a way, you can go 5 times 2 is 10. If you want to do the outside, inside at the same time, that's no problem. So you get 15I plus 2I is 17I. And then you have I times 3I is 3I squared, which is negative 3. It's a little shortcut if you're getting used to doing them and you're getting pretty good at it. That's fine. Okay, on the bottom, I'm going to square A, and I'm going to square B. I'm going to add them up. So my answer would then be 10 minus 3 is 7, plus 17I over 13. Now, I'm fine with that answer, but the book might write it like this, 7 over 13 plus 17 over 13I, so that it's in A plus BI form. A is 7 over 13, B is right there. Either way, I'm fine. I'm fine with you leaving it like that. Okay? Do you remember doing those last year too? A little bit? Yeah. All right, and that's going to be it.